Welcome back. Well, the hardest part about this was remembering that you weren't solving for the hypotenuse, you were solving for one of the legs of the right triangle, which means that in your solution, you should eventually get to a subtraction of squares instead of an addition of squares here. And you're going to see that as we go through this process together here. We start off here with the Pythagorean theorem using capital letters here. That's okay. It's the same connection, isn't it? And in this case, we can actually, if we want to, we can plug in what we know here for A and C here. That's okay. But if we're going to solve for b squared here, we're going to have to subtract this from both sides here. Well, we can do that after squaring both of these things. Now we have to subtract this from both sides here. So if we subtract 559504 from both sides here, it disappears from here, and 837225 becomes 277721. All right, but that's equal to b squared, not b. And so if we take the square root of both sides here, we find that b is equal to 52.7 pounds here. So 52.7 pounds here, that kind of makes sense. It's less than 74.8, and it's not producing as much of an effect here as force A is. So that seems pretty reasonable here. All right, so let's move on to some more specific triangles here, some special cases of right triangles here, in which we can even get more accurate and more reliable in terms of the relationships between the sides here. So the isosceles right triangle here first. So an isosceles triangle, as you recall, is a triangle that's got two of its three sides the same length here. All right, so if it's a right triangle, then those two sides have got to be the legs of the right triangle here as being the same here. Now, one of the things that we mentioned about an isosceles triangle, in addition to these two sides being the same size, the base angles of the right triangle, of the isosceles triangle rather, also have to be the same. So in addition to these two sides being the same, these two angles also have to be the same. And if we know, for example, that all of the angles have to add up to 180, we already get 90 degrees with this angle here. So 180 minus 90, that gives us 90 left over here, and these two angles have to be the same size, so we have to take 90 and divide it evenly between these two angles, so what's left for each one of them is 45 degrees. This is a 45, 45, 90 degree triangle here, an isosceles right triangle. So the question is, what do these things look like here when we apply the Pythagorean theorem to these things? So what I'm going to say here is that I don't know what the length of this side is. I do know that the length of this side and the length of this side are the same. So these are the two legs of the right triangle. I'm just going to plug that in for A and B here, and I'm going to see what I get for C when I do that. So C squared is equal to a squared plus b squared, but we've set this equal to x because we know it's the same number, so it's going to be x squared plus x squared. Combining like terms, I get 2x squared. So what I get now is c squared is equal to 2x squared, and so if I take the square root of both sides, what's that going to look like? The square root of 2x squared is going to be the square root of 2 times the square root of x squared. Well, I don't know about the square root of 2, but the square root of x squared, that's just x. These two things cancel each other out. So this is the square root of 2 times x, or x times the square root of 2 here. So in other words, if this distance here is 1, and of course that means this distance here is 1, then that means that this distance here is going to be 1 times the square root of 2. If this distance here is 5, then of course this distance here is also going to be 5, and this distance here is going to be 5 times the square root of 2. That's the relationship between each one of these sides of a 45, 45, 90 degree triangle. Always, always, always. All right, so that's our answer that we get for C, and that's the relationship that this has to the other two sides. So let's actually use this here. Find the hypotenuse of an isosceles right triangle that has equal sides of 2 meters. 2 meters here and 2 meters here. Find the length of this to the nearest thousandth. Take some time for that. Back in a moment.